Good morning. Today we are going to learn the most important theorem, that is tangent segment theorem. Statement of this theorem is tangent segments drawn from an external point to a circle are congruent. Now here is one circle given with center A and there are two tangents, that is line PD and line DQ are the two tangents. Now what is meaning of tangent segments? These are the parts of tangents. Now segment DP and segment DQ are the two tangent segments. Segment DP and segment DQ are the two tangent segments drawn from an external point. Now point D is external point. External point means it is outside the circle. Now point D is an external point and there are two tangent segments to the circle, that is segment DP and segment DQ, and we have to prove these two tangent segments are congruent, means DP is congruent to DQ. This we have to prove. Now diagram is already drawn here. Now next step is to write given. Now what is given in this diagram? That is, there is a circle with center A, that is in a circle with center A, in a circle with center A, in a circle with center A, segment DP and segment DQ are the two tangent segments. Segment DP and segment DQ are two tangent segments. Now next step is to write to prove. What is to prove here? We have to prove these two tangent segments are congruent. Tangent segments are congruent, means segment DP is congruent to segment DQ. Segment DP is congruent to segment DQ. This is how to prove. Now next step is proof, but before proof we'll do one construction here. We'll draw segment AD, we'll draw radius AP and radius AQ. This is our construction. Draw segment AD, segment AP and segment AQ. Draw segment AD, segment AP and segment AQ. Now next and last step is proof. Proof is very simple. Now because of this construction we have got two triangles. Observe these two triangles, that is triangle APD and triangle AQD. Simply we have to prove these two triangles congruent, then straightforward we will get this required result, that is DP is congruent to DQ. Only target is to prove these two triangles congruent. Now in triangle APD and triangle AQD, in triangle APD and triangle AQD, what are congruent parts in these two triangles? Observe AP and AQ, are these two congruent? For that, observe this circle and point A is center of the circle, therefore AP and AQ are the two radii of same circle, and radii of same circle are always congruent, therefore segment AP is congruent to segment AQ, reason radii of same circle. That is side AP is congruent to side AQ, reason radii of same circle. AP is congruent to AQ. Now AD is congruent to AD, reason common side. Side AD is congruent to side AD, reason is common side. AP is congruent to AQ, AD is congruent to AD, common side. We want one more condition. For that, observe radius AP and this line is a tangent and point P is point of contact, and by using tangent theorem that you have learned during previous session, the angle between radius and tangent is 90 degree, means radius is perpendicular to tangent or tangent is perpendicular to the radius at the point of contact. Therefore, angle APD is 90 degree. Similarly, DQ is radius and DQ is tangent and AQ is radius. Therefore, angle between tangent and radius is right angle or 90 degree. Hence, we will get angle APD is congruent to angle AQD, reason each 90 degree. Angle APD is congruent to angle AQD, reason each 90 degree, or tangent theorem also we can write, since both are perpendicular because of tangent theorem. APD is congruent to AQD, each 90 degree, or tangent theorem. Hence, these two triangles are congruent by triangle APD is congruent to triangle AQD by which test? For that, these two are right angle triangles. Observe, these two are right angle triangles and their hypotenuse is congruent. AD is hypotenuse and it is common for these two triangles, therefore it is congruent, and one pair of sides is congruent. Therefore, both are right angle triangles and hypotenuse and side is congruent. Therefore, by hypotenuse side test, these two triangles are congruent. Hence, triangle APD is congruent to triangle AQD, reason hypotenuse side test. Now, last step, since these two triangles are congruent, therefore their corresponding sides are also congruent. That is, side DP is congruent to side DQ, means segment DP is congruent to segment DQ. Hence, segment DP is congruent to segment DQ. Reason, corresponding sides of congruent triangles. Hence, we will get segment DP is congruent to segment DP. DP is congruent to DQ, reason corresponding sides of congruent triangles. Hence, the proof. This is most important theorem for your exam. Observe it again. What is the statement? Tangent segments drawn from an external point to a circle are congruent. There is a circle with center A. Point D is an external point to the circle and there are two tangent segments. There are two tangents first, that is line DP and line DQ are two tangents, and segment DP and segment DQ are two tangent segments. Now we have to prove these two tangent segments are congruent, that is segment DP is congruent to segment DQ. DP is congruent to segment DQ. For that we will do construction, that is drawing segment AD, AP and AQ. We will get two triangles. By proving these two triangles congruent by hypotenuse side test, we will get segment DP is congruent to segment DQ, reason will be corresponding sides of congruent triangles. It's about tangent segment theorem. Now move towards practice set 3.1. Take screenshot if you want. We'll move towards practice set 3.1. Practice set 3.1, question number 1. Or example number 1. One diagram is given, that is one circle with center C. There is one circle with center C. And one line is given, I think, which is tangent. There is circle with center C, and line AB is a tangent at point A, which is given, and answer the following questions. First question is, what is the measure of angle CAB? First question is, what is the measure of angle CAB? There are total 4 questions that we have to answer. First question is, I am not going to write question here. What is given in this diagram? Point C is center of the circle. Line AB is tangent to the circle at point A, means point A is point of contact, and radius of the circle is given as 6 centimeter. Radius of the circle is given as 6 centimeter. And the first question is, what is measure of angle CAB? What is measure of this angle? By using tangent theorem, line AB is tangent at point A, and segment CA is radius, which connects center and point of contact, that is CA is radius, and line AB is tangent. Therefore, angle between radius and tangent is obviously right angle. Hence, by tangent theorem, this is the answer of first question. By tangent theorem, measure of angle CAB is equal to 90 degree. Measure of angle CAB is equal to 90 degree. Means radius CA is perpendicular to tangent AB. Now we'll move towards second question. What is the distance of point C from AB and why? What is the distance of point C from line AB? Distance of point C from line AB, and distance is the shortest, is always perpendicular. Hence, distance of point C from line AB is nothing but segment CA, and it is nothing but radius, and it is given as 6 centimeter. Hence, distance of point C from line AB, distance of point C from line AB is equal to length of segment CA. Length of CA, that is given as 6 centimeter. Answer of second question is 6 centimeter. Answer of first question is 90 degree. Now we'll move towards third question. Third sub question. Distance AB is given as 6 centimeter. AB is given as 6 centimeter. Then find distance BC. What will be distance BC? Now in third sub question, AB is given as 6 centimeter and we want length of BC. Now observe this right angle triangle, that is CAB, which is right angle triangle, in which CA is given as 6, AB is given as 6. Then we can find CB by using Pythagoras theorem. That is, in right angled triangle CAB, by Pythagoras theorem, CB square is equal to CA square plus AB square. CB square is equal to CA square plus AB square. That is equal to 6 square plus 6 square, that is 36 plus 36. Therefore, CB square is equal to 72. CB is equal to root 72, that is 36 into 2, that is 6 root 2. CB is equal to 6 root 2 centimeter. Observe this again. CA is given as 6, AB is given as 6, and we want CB. By Pythagoras theorem, we will get CB square is equal to CA square plus AB square. CB square is equal to CA square plus AB square, that is 6 square plus 6 square, that is 36 plus 36. Therefore, CB square is equal to 72. CB is equal to root 72, that is 36 into 2 again. Taking 36 outside, we will get CB is equal to 6 root 2 centimeter. 6 root 2 centimeter. Now the last question is, what is the measure of angle ABC? What is the measure of angle ABC? What is measure of this angle? For that, observe this triangle again, ABC, which is right angle triangle. Also it is an isosceles triangle, since AC is congruent to AB. AC is congruent to AB. AC is given as 6, AB is also given as 6. Therefore it is an isosceles triangle also. Now, since it is an isosceles triangle, the angles opposite to congruent sides are congruent. Therefore, AC and AB are congruent. Therefore, angles opposite to congruent sides are congruent. Therefore, these two angles are congruent. Means angle ACB is congruent to angle ABC. Reason, isosceles triangle theorem that you have learned during previous year. Isosceles triangle theorem. ACB is congruent to ABC. Now sum of all the three angles is 180 degree. Now measure of angle ACB plus measure of angle ABC plus measure of angle CAB is equal to 180 degree. Now since we want ABC, therefore replacing ACB by ABC, we'll get measure of angle ABC plus again measure of angle ABC plus CAB is 90 degree is equal to 180 degree. Listen again, replacing ACB by ABC, since ACB ABC are congruent, that is 2 into measure of angle ABC is equal to 180 minus 90 degree, that is 90 degree. Now taking 2 that side, we will get measure of angle ABC is equal to 90 upon 2, that is 45 degree. Therefore measure of angle ABC is 45 degree. See once again, in triangle ABC, AC is congruent to AB, which is given 6 cm, 6 cm. Therefore the opposite angles are also congruent. That is ACB is congruent to ABC. Reason is isosceles triangle theorem. Now sum of all the three angles is 180 degree. That is ACB plus ABC plus CAB is 180 degree. Replacing ACB by ABC, will get ABC plus ABC plus 90 degree. This one is 90 is equal to 180. And after calculation, we will get measure of angle ABC is equal to 45 degree. That is the answer of fourth sub question. Take screenshot if you want, and we'll move towards question number 2 or example number 2. Now in this figure, point O is center of the circle and segment RM and RN are two tangent segments. Length of OR is given as 10, OR is given as 10 centimeter. Find radius, and radius of the circle is 5 centimeter. Radius is given as 5 centimeter. And the question is, there are 3 sub questions. There are three sub questions. First one, what is the length of each tangent segment? Means we want length of RM and RN both will be same. What is the measure of angle MRO, measure of angle MRO and measure of angle MRN? There are three sub questions. First one, we have to find length of RM and length of RN. We simply will find RM, that will be same for RN since tangent segments are congruent, that we have proved just now. That is RM is congruent to RN, means only we have to find RM. For that, observe this triangle, that is triangle OMR. In this triangle, OM is radius and RM is tangent, therefore measure of angle OMR is right angle, reason is tangent theorem. Now OR is given, that is 10, OM is given as 5 and it is a right angle triangle, hence by Pythagoras theorem we can find out RM and that is same for RN. Solution for first sub question. Segment or radius or by tangent theorem, measure of angle OMR is 90 degree. Measure of angle OMR is 90 degree. Hence, in right angle triangle OMR, by Pythagoras theorem, in right angle triangle OMR, by Pythagoras theorem, we can write hypotenuse square is equal to sum of squares of remaining two sides, that is OR square is equal to OM square plus MR square. OR square is equal to OM square plus MR square. But OR is given, that is 10 square is equal to OM is also given, that is radius 5 square plus MR square. 10 square is 100. 10 square is 100 is equal to 5 square is 25 plus MR square. Therefore, we get MR square is equal to 100 minus 25, that is 75. MR square is equal to 100 minus 25, that is 75. Therefore, MR is equal to square root of 75, that is root of 25 into 3. Taking 5 outside, we will get 5 root 3. Hence, by tangent segment theorem that we have proved just now, by tangent segment theorem, tangent segments drawn from an external point are congruent. Hence, RM is congruent to RN. RM is equal to RN is equal to RM is MR, that is 5 root 3. Therefore, RN is also 5 root 3. Means RM is equal to RN is equal to 5 root 3 centimeter. This is the answer of first sub question. Now we will move towards second sub question. What is second sub question? That is, we have to find measure of angle MRO, measure of this angle MRO. For that, OR is given as 10. For that, observe this triangle again, that is in right angle triangle OMR. OR is hypotenuse which is given as 10 and this side which is opposite to this angle is given as 5. And what is the relation between 5 and 10? 5 is half of 10. And since one angle is right angle and 5 is half of 10, therefore that angle opposite to that side must be 30 degree by using converse of 30, 60, 90 degree triangle theorem. Observe this triangle again. One angle is 90 degree which is given by tangent theorem and hypotenuse is half of one side. One side is half of hypotenuse. Therefore, angle opposite to that side is 30 degree by using converse of 30, 60, 90 degree triangle theorem. It is in triangle OMR. in triangle OMR. OR is 10 and OM is 5. OR is 10 centimeter and OM is 5 centimeter. Hence, OM is equal to half of OR. That is 5 is half of 10. OM is half of OR. Hence, by converse of 30, 60, 90 degree triangle theorem, by converse of 30, 60, 90 degree triangle theorem, this angle opposite to that side, which is half of hypotenuse, angle opposite to that side, which is half of hypotenuse, is 30 degree, and this side is half of hypotenuse, and angle opposite to this side is this one, and that will be 30 degree. That is, measure angle MRO is equal to 30 degree. Measure of angle MRO is equal to 30 degree. Now third sub question. Now third one is we have to find measure of angle MRN. This one. Now since measure of angle MRO is 30 degree, similarly we can prove measure of angle NRO also 30 degree by using same reason here. This is right angle triangle. This is hypotenuse. This is that side which is half of hypotenuse. Therefore angle opposite to that side is 30 degree. Therefore similarly measure of angle NRO is 30 degree. Hence, measure angle MRN is 30 plus 30, that is 60 degree. Listen again. Similarly, measure angle NRO is 30 degree. Measure of angle NRO is 30 degree. But we want measure of angle MRN, and that is addition of these two measures or addition of these two angles, that is MRO plus NRO. Hence, measure of angle MRN is equal to measure of angle MRO plus measure of angle NRO. That is 30 degree plus 30 degree, that is equal to 60 degree. See once again. Measure of angle MRO is 30 degree. Similarly, measure of angle NRO is 30 degree. Hence, MRN is equal to 30 degree plus 30 degree, that is equal to 60 degree. Take screenshot. Now we'll move towards example number 3. Diagram is same. Example number 3. What is given? Segment RM, names are also same. Segment RM and segment RN are tangent segments to a circle with center O. Prove that segment OR bisects angle MRN and angle MON. See, there is a circle with center O. Segment RM and segment RN are the two tangent segments drawn from an external point R, and we have to prove segment OR bisects angle MRN and angle MON. Bisects means it divides that angle into two equal parts. Means we have to prove OR bisects MRN, means we have to prove these two angles congruent. Similarly, OR bisects MON means we have to prove these two angles congruent. Very simple. We have to prove these two angles congruent and these two angles also congruent. For that we have to prove these two triangles congruent. Hence by CACT we will get these two angles congruent, and again by CACT we will get these two angles congruent. Hence segment OR bisects angle MR and MON. Means your target is to prove these two angles congruent and these two angles congruent. For that we'll start with these two triangles, that is this one and this one. It is in triangle MOR. Solution: in triangle MOR and triangle NOR. In triangle MOR and NOR, what are congruent parts? That is OM is congruent to ON. Side OM is congruent to side ON. Reason: radii of same circle. OM is congruent to ON. Radii of same circle. Then segment OR is congruent to segment OR, or side OR is congruent to side OR. Reason: common side. And we can take RM congruent to RN, that is tangent segment theorem, or also we can take these two angles congruent, reason tangent theorem. Means if you take RM congruent to RN, then test will be SSS test, and if you take these two angles, then test will be hypotenuse side test. Any test you can choose. We'll take these two angles congruent, that is angle OMR is congruent to angle ONR. Reason is tangent theorem, or each 90 degree. Hence triangle MOR is congruent to triangle NOR. Reason: these two sides are congruent, this side is common side, and these two angles are congruent. Reason is hypotenuse side test. Hypotenuse side test. And in place of these two angles, if you take these two sides congruent, reason tangent segment theorem, then these two triangles are congruent by SSS test. If you take RM congruent to RN by using tangent segment theorem, then these two triangles are congruent by SSS test. Any you can take either these two sides or these two angles. Hence these two triangles are congruent by hypotenuse side test. Hence angle MRO is congruent to angle NRO. Angle MRO is congruent to angle NRO. Reason: corresponding angles of congruent triangles. Now since these two angles are congruent, hence segment OR bisects angle MRN. Hence segment OR bisects angle MRN. Similarly, or also like these two angles congruent, these two angles will be also congruent. That is angle MOR congruent to angle NOR. Angle MOR is congruent to angle NOR. Reason is same, that is CACT, corresponding angles of congruent triangles. Hence similarly segment OR bisects angle MON. Segment OR bisects angle MON. Means segment OR bisects angle MRN and also angle MON. Segment OR bisects angle MRN and MON. Very straightforward solution. Simply we have to prove these two triangles congruent either by SSS test or hypotenuse side test. Now since these two triangles are congruent, therefore these two angles are congruent, that is CACT, and since these two angles are congruent, that is hence OR bisects MRN. Similarly these two angles are congruent, CACT, hence OR bisects angle MON. Hence proved. Now we'll move towards last example, that is question number or example number 4. Take screenshot. Example number 4. What is the distance between two parallel tangents? Two parallel tangents of a circle having radius 4.5 centimeter and justify your answer. Say question. What is the distance between two parallel tangents of a circle? We'll draw a circle first. Suppose there is circle with center O and there are two tangents which are parallel to each other. Suppose line L and line M are the two tangents to the same circle and which are parallel to this parallel with each other. Suppose line L is tangent to the circle at point A, line M is tangent to the circle at point B. Now radius of this circle is given as 4.5. I'll draw AB. Radius is given as 4.5 and what is the distance between two parallel lines? Distance between line L and line M, that is 4.5 plus 4.5, that is 9 centimeter. Answer is very simple. Distance between two parallel lines is AB, that is AO plus OB, that is 4.5 plus 4.5, that is 9 centimeter. But the question is justify your answer. This is most important part of this question. We have to write justification why it is addition of these two, that is for why it is AO plus OB. We'll prove this or we'll justify this. Solution starts from diagram. Diagram is not given. Solution starts with diagram. Solution starts from here. Now since line L is tangent to the circle at point A and line M is tangent to the circle at point B, we'll draw one more line which passes through center of the circle and which is parallel to line L. This is our construction. Suppose line K. Listen again. Line K passes through point O and which is parallel to line L. This is our construction. That is draw line K parallel to line L and passing through center O. Listen again. We have drawn one more line, that is line K, which passes through center O and which is parallel to line L. Means line L is parallel to line K. Now line L is parallel to line M, which is given, but line L is parallel to line K, which is given. Line K now M, which is given. Line L is parallel to line M, which is given, and line L is parallel to line K according to our construction. Therefore, what is the relation between K and M? First line is parallel to second line is parallel to third. Therefore, first and third are parallel with each other. Listen again. First line is parallel to second, which is given. Second line is parallel to third according to construction. Hence, first and third are parallel with each other. Hence line K is parallel to line M. Hence line K is parallel to line M. Line K is parallel to line M. Now suppose there are some few points A, B, C, D and E. Measure of angle CAO or OAC is 90 degree, reason tangent is perpendicular to radius. Measure of angle OB is also 90 degree, reason tangent is perpendicular to radius. Measure of angle OAC is equal to 90 degree and measure of angle OBE is 90 degree. Reason is tangent theorem. Reason for both is tangent theorem. Now observe these two lines, that is line L and line K, which are parallel with each other. And what about these two angles, that is this one and this one? These two are interior angles, this one and this one. And since these two lines are parallel with each other, the sum of measures of interior angles is 180 degree. The sum of measures of these two angles is 180, but measure of this angle is 90, therefore remaining angle will be 180 minus 90, therefore this angle must be 90 degree. Listen again, these two lines are parallel, and since these two are interior angles, and since these two lines are parallel, interior angles are supplementary. Hence sum of measures of these two angles is 180 degree, but this angle is 90, therefore this angle will be 180 minus 90, therefore it is 90. Hence I am writing directly, that is measure of angle AOD, measure of angle AOD is equal to 90 degree. Similarly also observe these two lines, line K is parallel to line M and measure of this angle is 90 degree and these two angles are interior angles, therefore sum of these two angles is 180 degree. Out of these two angles, so this angle is 90 degree, therefore this angle will be remaining angle, that is 180 minus 90, therefore it is also 90 degree. Also measure of angle BOD is 90 degree. BOD is 90 degree, and these both statements will have reason interior angle test that we have learned previous year, interior angles test. Since these two lines are parallel, the interior angles are supplementary, and since these two are supplementary and one angle is 90 degree, therefore remaining angle will be 180 minus 90, that is 90. Same reason for these two lines are parallel, and therefore these two angles are interior angles. Since hence the sum is 180 degree, but out of these two this angle is 90, therefore this remaining angle will be 90 degree. Means AOD is 90, BOD is 90 degree. Now taking sum of these two angles, measure angle AOD plus measure angle BOD is equal to 90 plus 90, that is equal to 90 plus 90 is 180 degree. Now observe these two angles, AOD plus BOD is equal to 180 degree. What does it mean? These two angles forms linear pair. AOD plus BOD is equal to 180 degree. It means these two angles form, this one and this one angles forms linear pair, and since these two angles forms linear pair, ray OA and ray OB are opposite rays. That means A, O and B are on the same line. Listen again, since these two angles forms linear pair, hence ray OA and ray OB forms opposite rays. Hence ray OA and ray OB forms or are opposite rays. And since these two rays forms opposite rays, all these 3 points lies on the same line. Hence A dash O dash B. Hence A dash O dash B. And since these 3 are on same line, therefore we can add AO and OB and we'll get AB. Means we'll get AB is equal to AO plus OB. Hence AB is equal to AO plus OB. that is equal to AO is 4.5 and OB is 4.5. It's 4.5 plus 4.5, that is equal to 9 centimeter. Hence AB is equal to 9 centimeter, and that is nothing but answer of our question. That is, the distance between two parallel lines is 9 centimeter. And to get this A dash O dash B, we have proved this. To get A dash O dash B, we have proved all this. See once again, there are two parallel lines. Suppose line L is parallel to line M. There are two parallel lines, and we have to prove, and radius of this circle is given 4.5, and we have to find the distance between two parallel lines, that is AB. And to get AB, we have proved A dash O dash B, so that we can add AO and OB to get AB as 9 centimeter. And for that, we have drawn one line K which passes through center of the circle and which is parallel to first line, that is line L. This line K is parallel to line L and passing through center O. Now since line K is parallel to line L is parallel to line M, hence K is parallel to M. K is parallel to M means all these three lines are parallel with each other. Now observe these two lines, line L is parallel to line K, hence these two angles form interior angles, and since these two lines are parallel, interior angles are supplementary, means their sum of measures is 180 degree, but this angle is 90 degree, therefore remaining angle will be also 90 degree. Same for these two lines, these two lines are parallel, therefore sum of measures of these two angles is 180, out of these two is this angle is 90, therefore remaining angle will be 90. Hence this angle is 90 degree, this angle is 90 degree, but hence taking sum of these two angles, that is 90 plus 90, that is 180 degree. Hence these two angles forms linear pair, and both are on same line, hence OA and OB forms opposite rays, hence A dash O dash B, that means AB is equal to AO plus OB. AB is equal to AO plus OB, that is 4.5 plus 4.5, that is equal to 9 centimeter. Hence distance between two parallel lines is equal to AB is equal to 9 centimeter. This is about practice set 3.1. Take screenshot, and we'll stop here. Tomorrow we'll start next part of this lesson. Thank you.